Solve by factoring. Step 1. Get all the terms on one side of the equation and set it equal to 0. Step 2. Factor completely. Step 3. Set each factor equal to 0. Step 4. Solve. For our example, since everything is not on one side equals to 0, we need to add 6x to both sides of the equation. When we write our equation on the left side, we want to write it in descending order of the variable. So we want the largest exponent first, and then the next largest exponent, and then the constant. So 2x squared plus 6x minus 20 equals 0. Notice how I did not add 2x squared and 6x together. Those are not like terms because they don't have the same variable raised to the same exponent. Step 2, factor completely. So when I look at that expression, I have 3 terms, and so it's a trinomial, but I always want to factor out a greatest common factor first if I can. So all of those numbers are divisible by 2. So let's factor out a greatest common factor of 2 out in the front. So now, looking at our leftovers in the parentheses, I see 3 terms, so it's a trinomial. The a value is 1, so this is just basic trinomial factoring. So we want 2 numbers that multiply to negative 10, and those same 2 numbers need to add to positive 3. So 5 and 2, and one of the numbers has to be negative because we're trying to multiply to a negative number. And I'm going to make the smaller number negative because I'm trying to add up to a positive number. So x plus 5 and x minus 2 equals 0. So now we're multiplying 2 times x plus 5 times x minus 2. The only way we can multiply factors together and get an answer of 0 is if at least one of those original factors is 0. So for example, 2 times 0 is 0. Negative 8 times 0 is 0. 100 times 0 is 0. The only way I can multiply numbers together and get an answer of 0 is if one of the original numbers is 0. So I'm going to slide this over here, and I'm going to set each factor equal to 0 and solve for x. So 2 equals 0, x plus 5 equals 0, x minus 2 equals 0. Now that first equation, 2 equals 0, that is not a true statement. That doesn't make any sense. So we just cross it out. We're not going to use that. The other 2 equations, you just solve for x. So these are both nice, easy one-step equations. So we're getting x equals negative 5 and x equals 2. Like any equation, if we take our answers and plug them back into the original equation, we could check and see if it works or not. I'm not going to do that at the moment, but if you just were wanting to know if it worked, you could just check by plugging your answers back in to the original equation. On number 1, we want to get everything on one side equals 0. So I have to subtract 18 from both sides of the equation. And then we want to try to factor completely. So is there a GCF other than 1? No. How many terms do we see? 1, 2, 3. So this is a trinomial. The a value is 1, so it's a basic trinomial. So we're looking for 2 numbers that multiply to negative 18, and then those same 2 numbers need to add to 3. So 3 times 6 is negative 18, and since I'm trying to multiply to a negative number, one of my numbers has to be negative. I'm going to make the smaller number negative because I'm trying to add up to a positive 3. So when I go back over here to factor, I'm getting x minus 3 and x plus 6. Now that I've factored completely, set each factor equal to 0 and solve for x. So we have x equals 3 and x equals negative 6. On number 2, everything is already on one side equal to 0, so we don't need to worry about that part of the problem. So is there a GCF other than 1? No. How many terms do we see? 2. And it's subtraction, and both terms are perfect squares. So that means this is a difference of 2 perfect squares factoring problem. So that's the one where you take the square root of the first term and put that in the first slot of each set of parentheses. Take the square root of the second term, so square root of 9 is 3, put that in the second slot of the 2 sets of parentheses, make one positive, make one negative. Set each factor equal to 0 and solve for x. So we're getting x equals -3 and x equals 3. Why don't you pause the video and try the last two? On 3, when it says find the zeros of the following function, that's just another way of saying what are the x-intercepts, or what are the answers. You're just solving for x. Same thing back on number 2. They said find the solutions to the equation below. These are all just slightly different ways of asking the same question. You're just trying to solve for x on all of these. So on number 3, I'm going to get everything on one side. So I'm going to subtract 4x and I'm going to subtract 4 from both sides of the equation. And remember, when you're writing out your terms, you want to write them in descending order of the variable. So put your squared term first, your x term second, constant in the back, equals 0. Is there GCF other than 1? No. How many terms do we see? 1, 2, 3. So it's a trinomial. The a value is not 1, so this is advanced factoring. So that's that one where we want to find two numbers that multiply to whatever a times c is. Those same two numbers need to add up to whatever b is. So 3 times -4 is -12, and then the b value is -4. So -6 and 2 multiplies to -12. -6 plus 2 is -4. So we want to use those two numbers that worked to split our middle x term. So -4x is getting split into -6x and 2x. Then we're going to slide down the 3x squared in the front, slide down the -4 in the back, and then let's drag down that equals 0 so we don't forget that we're solving an equation. Now we want to group the first two terms in parentheses and group the second two terms in parentheses and do factor by grouping. So in my first set of parentheses, I have a GCF of 3x. Leftovers would be x minus 2. In the second set of parentheses, I have a GCF of 2. And then leftovers in parentheses, x minus 2. And then I'm going to factor out the x minus 2 in the front, and the 3x plus 2 in red stays in the back, equals 0. So now we've completely factored, so we want to set each factor equal to 0 and solve for x. So I'm going to slide up here to do that. So x minus 2 equals 0. And 3x plus 2 equals 0. And then we just solve like normal to get our answers. So x equals 2, and then 3x equals -2. So you have one more step for that second equation. We're going to undo multiplication by doing division. And then for our final answer, we have x equals 2 and x equals -2/3. And you could just leave your answer as a fraction. Just make sure it's reduced if you can reduce it. On that last one, number 4, everything is already on one side equal to 0. So let's try to factor. So is there a GCF other than 1? Yes, there is. 5x. So we want to divide out our GCF of 5x to start, and our leftovers are x plus 4. Set each factor equal to 0. Oh, sorry, leftovers. Looking at the leftovers in the parentheses, can we factor x plus 4? No, it's not a trinomial. It's not a difference of two perfect squares. There's nothing we could do with that. So now that we have factored completely, set each factor equal to 0, solve for x. So we're undoing multiplication by doing division, and then I'm undoing addition by doing subtraction. So I get x equals 0 and x equals -4. And that is it.